So let's get on to a quick Azure overview and what services are we going to use. As you can see right now, I am already on Azure portal, and it is possible to use a free subscription for this exercise, for this course, if you want. Just create a new one and you are free to go. Microsoft actually supports a lot of free services, so it is possible to use those free subscriptions, and then when you move to the pay-as-you-go, to keep on using some of the free services that we are going to use in this exercise even afterwards. For example, the web app of a free tier. But first of all, let's discuss what services we are going to use and how they will be structured. Because this exercise is pretty simple, we are not going to have too many of those, but if you try to create a new resource, you could be overwhelmed with a number of different services that are available for compute, for databases, and so on. For us, it will be pretty simple, and actually what we are going to use is a web app. Those web apps usually how services and resources are structured in Azure. They are bundled together under different resource groups. For the web app, it will be a simple one, so you can create it using the portal and the UI if you would want to get some sort of a experience first, how it will look like and what other properties are available. When you create a new one, you need to select which subscription it will be hosted and what is a resource group. And you can create new resource groups, as many as you want. Those will be created, all of them, they will be created when you try to finally create the resource. The interesting bit about the web apps is that they all hosted by Microsoft, and Microsoft provides you this domain name for them. So whatever is their web app name and then .azurewebsites.net, it will be available worldwide and for anyone who knows their web app name. But there leads a limitation that each of the web app names, they need to be unique across all of their Azure subscriptions, not only yours, but all of the customers from Microsoft. So sometimes you need to be a little bit more creative, and just test will not really cut it. The next interesting bit is that how are you going to publish your code, and based on this, it will be really different how you will host the application. There are three options at the moment. You can have it as a code, so your application will be running in that web app itself. Another option is to run it as a container, the Docker image. And the final one is that you can host it as a static web app. So basically there will be no code and just the HTML. You can still have obviously the JavaScript code on the client side, but not on a server side. My personal preference and what we are going to do in this course is that we are going to host the application as a container that will be running in the web app. I think it has a number of benefits. I will not really jump into why Docker is good and what it is giving you, but just sufficiently to say that first of all and the foremost, it eliminates the issue works on my machine, and then you deploy it to your production environment, and suddenly everything is different, and it doesn't really work because you miss some of the dependencies. With Docker images and containers, basically you have the benefit of testing that the application and all of the dependencies packed together, and if it works on your machine, then it will work on the application on the production or different environments where you deployed it. And then you need to pick what operation system that you want to run it under. There are two options, Linux or Windows. Doesn't really matter which you choose, up to you. Just historically, Linux is the way to go. and then a couple of questions or options how you're going to host it, so under which region geographically. That will help in terms of latency so you can imagine that if you deploy something to Australia and try to use it from Europe, then the traffic will not be that fast if it will be deployed basically next to you. And after that, you need to pick or create a new application service plan. That is basically the virtual machine or set of virtual machines that actually host your application and run it. It is possible to run multiple web apps under the same application service plan. And the only limitation there is that both the application service plan and the web app needs to be deployed to the same region. And if you have it, then it is done, and you can save your cost that way. The last thing about the application service plan is that this is the way how you pay Microsoft for your services. So the web apps themselves, they are free, but the application service plan, that what incurs the cost, and you can select different tiers of them. There is a free one available, and it will be available for all of the time, and we can use it for our exercise. The only limitation there would be the number of compute resources and minutes that we can have for us that way. The next thing that we are going to use in our exercise and the service that we are going to use, it is the storage account. So the storage account is used to save stuff on the cloud, and once again, as usual, you need to put it into one of the resource groups. How we are going to use it is that we are going to save the Terraform state in the storage account on a cloud, so it's not committed into our Git repository, and instead all of the developers who work on the same project, they can work on it with the same foundation pretty much. There are a couple of options that you can pick for the storage account. It would be the performance, so how fast the data needs to be available, and the redundancy of data, so if it needs to be saved on a second location, and that you would have a backup in a fast way. In our exercise, because it will be only for the Terraform state and it's for the testing purposes, I'm going to pick the locally redundant storage, so pretty much it would mean that we don't have any good backups. I'm not going to create any of those resources at the moment, and instead I will open the already created pizza selector dev. It is saved under the resource group named dev at the moment. And what you can do here, first of all, you can browse how the application looks like. So you can click on this browse button, or you can click on the default domain. And as I said before, the name of the default domain, it is the name of the application.azurewebsites.net. So when you open it, it will open our random pizza generator application. What you can do here is through the portal, through that UI, you can always change any of the settings, and you can do that as you please. But once again, that's what I meant, that with so many options available, it is very easy to forget some of the changes that you made in one of your environments, and do not recreate or redo those changes in your follow-up environments. And that actually is a really good segue to the final topic that I wanted to touch base right now, the environments. As you develop your application locally, you most likely will run your code locally once again and verify that everything works as you expect it to be. But then if you want to deliver something to your customers, you need to deploy it to the cloud. And there you would have the challenge that how do you maintain and how can you verify that whatever you developed locally actually works exactly as you expect on a cloud. The way to solve it is to have multiple environments, so it is preferred to have at least 2 of them, but the more the better. It's the question of price and how much effort do you want to invest to maintain those environments. But as I said, at the very least you want to have at least 2 environments, one of them for dev or non-prod, and the final one is the actual production environment. It is possible to hide some of the non-prod environments if you would want to, but it's outside of the scope of this exercise. What you want to have is that on your dev environment you would verify that your deployment process is actually working as expected and all of the settings are correct, and you can break this dev environment or non-prod environment whenever you want, but then you have the actual production environment which should be stable and up all of the time, and that's what will be used by your customers. In order to run those tests, it is better to have your non-prod environment, if you have only a single one, as close to your production environment in terms of settings. So for example, if you have for the web app, if you have application service plan of, let's say, tier P2 v2 to manage all of the load, or P3 v2, then you would want to have the same one in your non-prod environment to be able to run, for example, all of the performance tests. But if you have a separate dev environment, then UAT environment and production environments, then only the prod and UAT needs to be of a similar tier, and dev can be a little bit cheaper just to save the cost. And how it is possible to create all of those different environments? Well, there are a couple of options. The simplest one is that you can just have multiple resource groups and call one of them dev, another one QA, and the final one is prod. You are limited with this approach is that all of the resources for a given environment needs to live in a single resource group, or you would have to create multiple resource group with suffixes like -dev every time. So it can be a little bit annoying to maintain and manage. And I would say the better solution would be actually to create multiple subscriptions. The subscriptions themselves, they don't really incur the cost by themselves. It's only the resources that are inside of them. And if you want, you can create dev subscription as I have it right now. And for example, you can create a second subscription that would be prod. It will be under the same billing account and the billing profile, and the payment will be over there. But then for this prod subscription, when you create it, you can have as many of the resource groups under this subscription, and you would be able to create different service principals that would have different scopes. So different subscriptions in general give you much better separation of your environment, so you don't accidentally mess things up and do some unexpected changes in your production environment while you wanted to do something in your non-prod environment only. Okay, so with that, let me rephrase quickly. In terms of the Azure services, we are going to use only 3 of them: the storage account for Terraform State, the application service plan to host our application, and finally the web app to run it. And the second part is that it's better to have different environments, and my preferred way to separate those environments is to use different subscription for them.